Okay, so we're going to start today with the problem solving chapter. The first concept we will discuss here will be percentages. We've heard about percentages our entire life, so it should be something everybody is familiar with. We're talking about part per 100. So the simplest way to calculate a percentage is the percentage is equal to the part over the whole, and then of course multiplied by 100%. Now let's look at this first example here. 683 people out of 800 people state that they like dogs. What percentage this? Well, the part is 683 and the whole is 800. Multiply that by 100%. So take 683 divided by 800, which gives us 0.85375 times 100%. In your calculator, you just hit 100. And that gives us 85.375%. And that's it. Okay, another example. Again, write the following value as a percentage. Now we already have it as a part over the whole. So 3/4 times 100%. 3 divided by 4 is 0.75 times the 100%, or 75%. Okay, now our next one is the decimal. Now, if you remember, your decimal first place is the tenth, and the second place is the hundredth. So this is equivalent to 1 over 100. Which we don't need to do. This is essentially got the division completed already. So here we simply need to multiply by 100% and we get 1%. Same thing here, simply multiply by 100% and we get 35%. And here we have it written out for you. Okay, now, example 3. The sales tax in Pensacola is 7.5%. How much tax is on a $319.99 purchase? Now, we can't multiply by percent, so we have to change these to decimal. You may have already learned this in the past. So to take a percentage and convert it to a decimal, you simply move the decimal place 2 places. So we took it here and we moved it there. So now we simply do simple multiplication. 319.99 times 0.075. And this will give us our sales tax. And that is 23.99925, which would round up to $24. That's it. Okay, the value of a 2004 BMW M3 dropped from 14,000 to 12,000 over the past year. What is the percent decrease? Well, first, what is the decrease? 14,000 minus 12,000, which is 2,000, is the decrease. So the part is 2,000. The whole is the original 14,000. So we simply have 2,000, our percent equals 2,000 over 14,000 times our 100%. And this is equal to 0.14, and let's round to 4 decimal places, 29. Times our 100, so we're moving our decimal place 2 places essentially. And we get 14.29%. Okay, the next concept we come up to is something called absolute change. Absolute change is the absolute value of the ending quantity minus the starting quantity. Now, what the absolute value does is whatever you calculate within those signs, these here, if you're not familiar with it, you just make it positive. And then the relative change is the absolute change divided by the starting quantity. So let's take a look at our example here. Suppose a stock drops in value 60% one week, then increases in value the next week by 75%. Is the value higher or lower than when it started? So let's see. Easiest way to do a problem like this is to just set original value equal 100. So it drops 60%. 60% of 100, which would be 0.60. 100 times 0.60, that's 60. That's the decrease, so that brings it down to 40. Now it increases by 75%. So 75% of 40, which is 0.75, is 30. So our new value is 40 plus 30, which is 70. So is the value higher or lower? It is lower. Basketball player scores on 40% of the two-point field goal attempts and 30% of the three-point field goal attempts. Suppose the player attempted 200 two-pointers, so let's write this down. 200 two-pointers at what, 40%? And 100 three-pointers at 30%. What is the player's overall field goal percentage? So what we need to do is calculate 40% of 200. It's simply 200 times 0.40, which is 80. And we need to calculate 30% of 100, 0.30, which is 30. So the total number of shots completed was 110. This is the part. And 300 is the total number of shots, so that's the whole. So again, our percentage is simply 110 over 300 times 100%. And 110 divided by 300 is 0.366. And again, we'll stop at 4 decimal places, which is 36. Moving to decimal place 2, 36.67%. Okay, so the next idea we're going to talk about is rate. Rate is a ratio of two quantities. A unit rate is a rate with a denominator of 1. So you can drive your car 300 miles on a tank of 15 gallons. Express this as a rate in terms of miles per gallon. So this is 300 miles per 15 gallons. Doesn't say to reduce it, so that is one way to put it. Another way you could go ahead and reduce it and you would get 20 miles per 1 gallon. Both of those are equivalent. Or as you typically see it, 20 miles per gallon. That's how that comes about, in case you didn't know that. The next thing we're going to talk about is a proportion. Proportion is an equation showing the equivalence of two rates or ratios. So basically we have two rates or two ratios that are equal here. We have 5 over 3 is equal to x over 9. Now, how we solve this? Simply we cross multiply. So we multiply 5 times 9, and that should be equal to 3 times x. So 5 times 9 is 45. 3 times x, I want to know just what x is. So I divide both sides by 3. I get x equals 15. Okay, now we have another proportion equation here. We have 6 over 2 is equal to 4 over x. Again, cross multiply. We have 6 times x is equal to 2 times 4. 6x is equal to 8. So x equals 8 divided by 6. And unless it says to reduce it or put it in a decimal, that is fine. We can reduce this to x equals 4/3. And we could say x is equal to 1.33, and that's repeating, if you want it that way, depending on how it does. But unless it specifically says, I would leave it like this. Okay, another proportion equation. A map scale indicates that 1/2 inch on the map corresponds with 3 real miles. How many miles apart are two cities that are 2 1/4 inches apart? So what we may want to do here is take this 1/2 and convert it to a decimal. No, 0.5. For some reason my erased 1/2 equals 0.5, and 2 1/4 is equal to 2.25. So 0.5 is the 3 miles. That's 2.25 is 2 x miles. So again, cross multiplying. 0.5x is equal to 6.75. Divide both sides by 0.5. And we get x is equal to 13.75. And that would be miles. On these word problems, don't forget to include the unit. Okay. Another method to solving some of these problems is something called dimensional analysis. Process of multiplying a quantity by rates to change the units. Okay, from example 7, we found that you could drive 20 miles per gallon. How far can you drive on 40 gallons? And how many gallons are needed to drive 50 miles? So, if I can drive 20 miles for 1 gallon, I can drive, how far can I drive 40 gallons. And we're simply multiplying. What happens here is the gallon here and the gallon here cross each other out, and we get 800 over 1 mile, or 800 miles. Okay, now if I can drive 20 miles to 1 gallon, how many gallons 50 miles? And again, what happens here is this, and this cross out. I did that back. Let's do this again. And my eraser is not working well. That's 50 miles. Now how many gallons? Equal to 20 miles for 1 gallon. I have 20x equals 50. Divide by 20. We get x equals 2.5 gallons. Set that up as a proportion equation. I guess we could have done this one the same way. We could have done 20 miles for 1 gallon equals x miles for 40 gallons. And we get the same thing, 801. Okay. Bicycle is traveling at 15 miles per hour. How many feet will it cover in 30 seconds? Okay, well, I've run into this problem before. Okay, I can never remember that. So, we travel 15 miles in 1 hour. So how many feet is that? Well, 5,280 feet in 1 mile. So we end up with 15 times 5280. So we travel 79,200 feet in an hour. Now, how many seconds are in an hour? Well, 1 hour, then we have times 60 minutes in that hour, thus the hours go away. Times 60 seconds in a minute, so the minute goes away, and we get 3,600 seconds in an hour. So our basic setup here then is 79,200 feet and 3,600 seconds. That's feet per second. Do that division real quick. And this is 22 feet per second. But we want to know how far we travel in 30, so we simply multiply that. 30 and we get 660 feet. Now, there are other ways to do this. So if you know another way, do feel free to use it. Okay, so now we're going to talk about geometric shapes, area, and volume. Start with example 13 here. If a 12-inch diameter pizza requires 10 ounces of dough, how much dough is needed for a 16-inch pizza? Use the formula for the area of a circle, which is pi r squared. So we're given the diameter. We know that r is the radius, which is equal to 1/2 the diameter. So let's look at our 12-inch pizza. R is equal to 6, so the area of it is pi times 6 squared, or 36 pi square inches. And now let's look at our 16 incher. R would then be 8. Our area would be pi times 8 squared, which is 64 pi square inches. So here's what we know. We know that our 12-inch pizza takes 10 ounces of dough. So our 36 pi square inches takes 10 ounces of dough. Our 64 pi square inches takes some unknown amount. So when we cross multiply, we get 36 pi times x equals 10 times 64 pi. So here we still have our 36 pi x, and here we have 640 pi. Now we can divide by pi, which will simply get rid of that. So now I can divide both sides by 36, and I get x equals 640 divided by 36, which is 17.78 ounces, rounding to 2 decimal places. Okay. Website says you'll need 48 50-pound bags of sand to fill a sandbox that measures 8 by 8 by 1. How many bags of sand would you need to fill a sandbox that measures 6 by 4 by 1? And this was 48. So volume, remember volume is equal to length times width times height, which is what we have here. So this is what, 64 cubic feet, and this is 24 cubic feet. So for a 64 cubic foot one, takes 48 bags. For a 24 cubic foot one, okay, so 64 times x equals 1152. Divide both sides by 64. And we get x equals 18 bags. Again, when you're doing word problems, don't forget to put the unit. Okay. Suppose your heart beats 80 times per minute. How many times does your heart beat in a year? Okay, so we have 80 beats in 1 minute. Now there are 60 minutes in 1 hour. There are 24 hours in 1 day. And there are, this year is a leap year, so 366 days in a year. So here's what's going to happen. This minute is going to get rid of this minute. This hour will get rid of this hour. This day will get rid of this day. So we're going to end up with beats per year. And now we simply multiply across. I have 80 times 60 times 24 times 366. And that's a lot of beats. 42,163,200 beats per year. Okay, this is a favorite. Here's an old wise tale about, oh, wait, wrong question. The store has clearance items that have been marked down by 50%. They're having a sale advertising an additional 30% off all clearance items. What percent of the original price do you end up paying? This is another one where I would pick a value and just say let original price be $100. It's marked down 50%. Well, 50% is 0.50. So 50% of 100 is 50. Now I subtract that $50 and my sale price is $50. Okay, now they're digging off an additional 30%, which is 0.30, which would be 15. So I subtract 15 from the 50 and I get a final price of $35. It wants to know what percent. Well, the part, 35, the whole is 100, times the 100%, and that's what, 0.35 times our 100%, and that is 35. That is that. Okay. Car is traveling at 100 kilometers per hour. How far does it travel in 5 seconds? So, 1 hour, 1 hour, 60 minutes. Starting with 1 hour. Hit it again. You have 1 hour of time. 60 minutes and 1 hour. And there's 60 seconds and 1 minute. Again, hours cancel, the minutes cancel, and I get 3,600 seconds in an hour. And it travels 100 kilometers in that time. So how far does it travel in 5 seconds? Well, 100 kilometers is equal to 100,000 meters. Kilo meaning 1,000. So now we simply take our meters, 100,000, divide it by our seconds. and then multiply it by the number of seconds. So you get 100,000 by 3,600 times 5, and we get 138 point, and we'll go 2 decimal places, 89 meters. And that is it. Okay, this is the old wives' tale. A flash of lightning travels at the speed of light, which is approximately 186,000 miles per second. Sound of lightning, the sound of lightning, which is thunder, travels at the speed of sound, which is about 750 miles per hour. If you see a flash of lightning, then hear the thunder 5 seconds later, how far away is the lightning? Okay, the first thing to consider here is the light travels at such a speed that it's not going to matter. You can ignore it. Basically, what we need to find out is how far does sound travel in 5 seconds. So, as we calculated up here, there's 3,600 seconds in an hour. So if we take our 750 miles per hour, or per 3,600 seconds, and then multiply that by the number of seconds we have again, which is 5, now we get 750 divided by 3,600, 0.208, and a repeating 3, and we multiply that by 5, and we get 1.0417 miles. So that's a little trick some of you may have known, is if you see lightning, count, and for every 5 seconds you count, it's a mile away. So that's it for this chapter. I know this is not the most optimal way to do this, but hopefully in the fall we'll be back to regular classrooms. You guys have a good day, and I'll talk to you next time.